Okay, so there's M32, the set of 3 by 2 matrices. So typical is, well, let's just use typical matrix, right? Okay, is it a vector space? Well, if we add this to another 3 by 2 matrix, call it B11, B12, B13, C, B21, B22, B23. And I already screwed up. I said M32, then I wrote down a 2 by 3. So we're doing M23. Apologize for getting your hopes up about M32. Yeah, M32 would have 2 columns and 3 rows, right? So I'm just careless. Epidemic of that, nothing I can do about it. Okay, except hopefully recognize it before I go on. Okay, there, right? Do we have a 0 matrix? Additive identity? Do we have inverses? What do you add to this matrix to get this matrix? You add this one, right? This one plus this one equals this one. So this is the additive identity. Doesn't matter what the values of the A, 1, 1, and so forth are. And it doesn't matter what the values of these are. If these are exactly the opposite sign, when you add them, you get the identity. So you have an identity and you have inverses. Also, if you multiply this by any number, you still get a 2 by 3 matrix, right? Okay? Again, there are other properties you should be, I might ask you to verify some of it. See, here's another property, prove it. So you probably want to look at the other properties, but I'm not going to ask you to memorize what all 10 of them are. I mean, some lists only have 6. Okay? Okay. Well, that and a few more simple details prove that this is a vector space, right? What do you think a basis for this vector space would look like?